How many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? The key insight for these types of problems is that we need to set quantity of solute equal to quantity of solute. And so in this case, that's liters of salt equals liters of salt. We'll say that X is the amount of 25% saline solution that we add, and so the amount of salt contained in that will be 0.25 times X. And that's in addition to 10% times the 3 liters that we started with. And all of that salt must be equal to 15% times the total volume, and that would be X plus 3. So that's the hard part, getting the equation on the page. The algebra is easy, and that works out to X is equal to 1.5. The number A is 110% greater than the number B. The number B is 90% less than 47. What is the value of A? Now, this is a real gotcha question because most people who read it are going to say that A is equal to 1.1 times B. But it's not. That would be 10% greater than B. We need 110% greater than B. And so A is equal to 2.1 times B. The next part is a little more straightforward. B is 90% less than 47, so B is equal to 0.1 times 47. That makes A 2.1 times that, which is 9.87. 210 is p% greater than 30. What is the value of p? If you're solid with your percentages, then you might just say that 210 is 7 times 30, which is 700% of 30, or 600% greater than 30. To do this the algebraic way, we would say that 210 is equal to 1 plus p over 100, since p is a percentage, and multiply all that by 30. Solving for p, we also get 600. A book was on sale for 40% off its original price. If the sale price of the book was $18, what was the original price of the book? As tempting as it is to multiply 18 by 40% and then add that to 18, don't do that. The answer is not 2520 because that 40% off is referencing the unknown original price, not the 18. What we need is that 60% of some unknown number x is equal to 18, and so x is equal to $30. The positive number a is 2,241% of the sum of the positive numbers b and c, and b is 83% of c. What percent of b is a? We're interested in an equation that includes a's, b's, and constants, but no c's allowed. So from the first part, we have that a is equal to 22.41 times the sum of b and c, and then we have that b is equal to 0.83c. Now, here's where it gets tricky. We're really interested in solving for C, not B, because we'd like to make a substitution that leaves us with only A's and B's. So C is equal to B over 0.83. And I don't like that fraction. That's going to make it tricky to add to the B later. So what we have is 1 over 0.83B, and so that's 1.205B. And from there, we make our substitution, solve for A. We get that A is equal to 49.41B. But don't make the mistake of choosing answer choice B, because what we need is a percent, not a decimal, and so the answer is D, 4,941%. The number of zebras in a population in 2018 was 1.27 times the number of zebras in this population in 2014. If the number of zebras in this population in 2014 is p% of the number of zebras in this population in 2018, what is the value of p to the nearest whole number? I suggest we make up numbers to make this more concrete for ourselves. And so let's say that there were 100 zebras in 2014, and so there would have been 127 zebras in 2018, and that would make p 100 over 127 times 100, since p is a percentage, and that to the nearest whole number is 79. The number of crane flies in a wildlife sanctuary is 30% less than the number of ladybugs in the sanctuary. The number of honeybees in the sanctuary is 85% greater than the number of crane flies in the sanctuary. The number of honeybees in the sanctuary is how many times the number of ladybugs in the sanctuary. For this one, we just need an equation in terms of H, the number of honeybees, and L, the number of ladybugs, along with some constants. So to start, we have that C is equal to 0.7 L, H is equal to 1.85 C, and then we can make a simple substitution to get that H is equal to 1.295 L. Alma bought a laptop at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Let's say that X is the original price, so zero point 0.8 times X times 1.08 for the sales tax would give us P, and so solving for X, we get P over zero point 0.8 times 108. The regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What was the store's cost in dollars for the shirt? The first part of this is straightforward. We have that the sale price is $11.70 times zero point 0.2, which is $2.34. The second part is where most people get tripped up. We have that $2.34 is equal to 1.3 times this unknown cost to the store. And so solving for C, we get 2.34 over 1.3, which is $1.80. The result of increasing the quantity X by 400% is 60. What is the value of X? We have that X times 1 plus 4 is equal to 60, so X is 12. Most people, though, will pick B because 60 is 400% of 15, but it's a 400% increase from 12. Hongbo sold X cell phones in 2013. The number of cell phones he sold in 2014 was 128% greater than in 2013, and the number of cell phones he sold in 2015 was 29% greater than in 2014. Which of the following expressions represents the number of cell phones Hongbo sold in 2015? Now, if you've made it with me this far, then you're unlikely to be duped by those sneaky test makers and their percent greater than traps. So let's try this. We'll say that P is the number of cell phones that Hongbo sold in 2015. And so P is equal to X, the starting amount from 2013, multiplied by 2.28, which is the first year's increase, and then multiplied by 1.29, which is the second year's increase. And so the answer is D. To see more content like this, be sure to subscribe, and you should absolutely check out my next video on absolute values.